Always think about lifetimes. It's a C++ video. I like C++. I really enjoyed talking about it. We're gonna look at this and see what it means. We're currently getting const into the engine, okay? I'm starting to learn more about const. All right? What about lifetimes now? I don't really have lifetimes in the game other than array slots being open and then I fill in these slots. But let's see.
So last time I did a code review, I talked about how there was a resource manager that was written that wasn't quite right, that wasn't...
Resource manager, we have a bump allocator in the game. Very simple, but it works.
Quite how I would write a resource manager, and I gave a lot of like tips and ideas and just opinions really on how I would go about doing something like this. And what I thought I would try out today is a bit of a new format. We're gonna expand on that a lot more. We're gonna do a bit of programming here together, and I'm gonna actually show you what I mean rather than just talking. Got my coffee. I'm wearing my cozy sweater. There is even a lit candle in front of me. It's raining outside, which you probably can't hear. So let's just chill out.
Where does he live, man? For me, it's fucking million degrees, holy.
And do some programming together. Okay, so here is the code that we're going to be looking at today. If you want to see the full code review that I did, it was kind of more of a part one. But
Resource manager load sounds. It takes in a string for the sound name, yes, and then I guess he always has resources sounds. That path has to be there, and then he adds the sound name. So that's how I do it too. And a sound buffer. Okay, whatever that means. Maybe this is where he loads the file in. Sound, yeah, dot load from file path, yeah. And then if we are unable to load the sound, we're gonna throw an error. And if we are able to load the sound, then we add that to the array of sounds. So I would do this almost exactly the same thing, except for throwing. I would basically hard crash here. I don't throw, I hard crash. That's what I do at the moment because I'm developing the game. If the game is out in the public, I would maybe do something different, like trying to load the sound, then the sound doesn't load, and I will make it so that the program doesn't crash, but it tosses an error to maybe the console or to some log file.
Well, I'll have it linked up there. This is what we're going to discuss in a bit more detail and also probably rewrite. So first and foremost, let's kind of do a bit of a more thorough review of this specific...
Oh, by the way, so since we are talking about resources here, right, and we watched the video from Casey Muratori, a handmade hero, he would do it differently where he would return a stub if it doesn't work or he couldn't load the file. So you would just get a 0 file back and then use that file, I don't know, basically play, if it's a sound in this case, play nothing, I guess. So this is the different ways to do this, right? Because he doesn't like resources. Yeah, resources like sound and stuff. This is where they deviate in a way. Null objects, yeah.
Class, and we'll go into the details of why I think it needs work. So first of all, let's just have a look at this entire file. So it's a file called resourcesmanager.h. Yeah. It's got a whole bunch of different errors that are implemented as a subclass of this error resources manager that is a runtime error. So the author of this code obviously loves exceptions. I personally am not as big of a fan of exceptions in a language like C++. However, that's not what this video is about, so let's just ignore that. By the way, if you guys do want to check out like the context of this code for yourselves and actually see the project on GitHub.
It's a lot of old, but it doesn't mean it's bad.
So looking at the header file of this specific class, we get a pretty decent idea of its public API, which usually helps us understand.
Get texture, get region box. I wonder what that is. Get region airports. Okay. Weather tiles, facts. Ah, so this is related to maybe his game, right? Get sound. So the resource manager manages essentially everything from sprites to sounds, to, I guess, font and even regions in the game. Okay, interesting. I have input, sound, and rendering. These are all disconnected. And so the renderer cares about getting, for example, the texture. And then it's just reading a file. It's not like a resource, really. It's just reading a file. But it's also still not done in production. So that might change.
However, what I like to do, even more so, is actually have a look at how this code is actually used in the rest of the code base. This gives us a pretty decent look of everything that's possible with this API. However, it doesn't really give us a practical look at how it's used within the context of this project. So if we take a look at the main file, for example, which is right over here, then you can see, by the way, I did actually end up modifying this code a little bit from the original code in that code review video, but this is the context context of how it's initially used. This resource manager, we get the instance of it and we call .load, which takes us over here into this function where we explicitly load these kind of strings which refer to file paths of textures, sounds, and fonts that we want.
To me, this is totally disconnected. I would call it separation of concerns. So for example, the font files, in my opinion, the renderer should worry about the font files. So it shouldn't be in the resource manager, like you initialize your renderer, this is when you get the font files. And then for the sounds, I think the game should worry about loading the sounds whenever they're needed. For me, this looks like it's a bunch of concerns, I call this concerns, put into one place, which is called load. I know that a resource manager is supposed to give you resources, but in this case, the fonts are not being used by the game, but by the renderer. And so you're loading them here, but it's not clear where they go. I think having resources as its own separate thing is fine, especially when you take into account that you can bundle them into packages where they're mixed anyways. Yes, so I would do it differently where I say resource manager load font, and then the resource manager would be the one that's interacting with the packaged asset file. And you call this resource manager load font in the renderer when you're initializing the renderer or when you're changing the font of the renderer. This is what I would do. This is where I think it's fine. But I don't like the generic load function where it's completely disconnected and you don't know who's actually using this font. That's how I see it. Because then the renderer, you're initializing the renderer and the renderer depends on the font. But then the resource manager had to call load before the renderer could actually call init. That's a bit disconnected in my opinion and very error prone. That's how I see it. Could be wrong here, but that's just how I like doing it.
To load. And then if we go to something like the menu file over here, then you can see that we reference those assets that we loaded, such as this menu.png. We do that by just calling a resource manager instance and then get texture. So that is really surprisingly like the gist of this entire class. It just gives us a way to initially just like kind of blanket statement, just load everything that needs to be loaded, which obviously is specific to this particular project. And that effectively preloads all of the assets that we need from disk. And then what that enables us to do is anywhere in our code base, just reference that kind of global instance of the resource manager, the Singleton, and just call get texture or get font or get whatever to actually retrieve the asset that we want to use. So that in and of itself gives us a pretty decent idea of what this class is actually used for, as well as how it functions. So let's then talk about the specific issues that I have with this, as well as what we can do to actually improve the resource manager. So first and foremost, I don't like the fact that the resource manager is the actual body of code that does the specific loading of specific resources that are relevant to this project. I see the resource manager as more or less like a system that has an implementation that is treated like a black box. It's not something that you're supposed to be able to look into the implementation of or even have to modify the implementation of to get what you want out of it. That's a little bit weird. So ideally, what we want when using this resource manager is we have the resource manager over here, and then we have our code base over here. This line separates our code being like, hey, I want to load this specific like PNG file or whatever from the system that actually does the loading. So this is like the internal loading. And then this is simply a way for us to call into that code and tell it what to do.
Yeah, so for example, the renderer would call load me the PNG file or load me the true type font file. Or the game would be load me the sound file in this particular part of the game because I need this sound file here. And then it also says unload the sound file when I'm here. So that's how I like it more, because then you can be very specific in your game and nothing is hidden. You can see it clear as day where something is loaded and where something is not.
It will then store it, presumably, in some kind of data structure, and then we can request it by calling get, and then the resource manager somehow will like fetch it and deliver it.
I don't actually like get and load. I think it should just be, when we're talking about sounds, I think it should just be called play sound. Or maybe load sound, and then we have the resource at us. We don't need to get it anymore. We have like a reference to the sound that it gives us back, and then we use that reference to the sound or whatever we got back, and then say play. That's how I see it. I don't want to, but get is, I guess, is fine too.
To us. So notice how the actual files that we're trying to load, the assets that we're handling, which is kind of like user code, it's our code, is different from the code that is the system. This means that the user of this system never has to actually look into the system to find out how it works. Why is this an advantage? Honestly, lots of reasons, but the biggest advantage is that you don't have to understand any of this. You certainly don't have to modify the resource manager system. That's kind of above your pay grade. And it provides one of the best features of software development, reusability. You've created this generic piece of code that can be applied to lots and lots of different use cases. And I would probably go as far as to say that software development at its core is the balance between writing kind of generic code that can be reused easily, but balancing that with writing specific code that perfectly fits your given use case.
Yeah, because I think he's right here. I do that too. I think he's very right. So if we go and open up sound, you can see here that I have a generic interface that allows me to supply some options like looping and fading. And then a sound is just a generic thing that holds data. And the only interface that I actually have is play sound with options. I don't need to rewrite this at all. I just need to make sure that I have it in the game.
Because leaning too far into either generic reusable code or specific code usually results in a suboptimal solution. Now, for those of you just getting started with your computer science journey, I have the perfect thing for you. A 30-day free trial.
Perfect. We stopped the video yesterday. Before that happened, okay, I mean, we're gonna watch a little bit to support him, and then we skip past the ad, okay?
Brilliant.org, the sponsor of this video.
Yes.
Those of you who don't know what Brilliant.org is, it's an amazing website filled with lots and lots of really high-quality courses on various STEM topics. As I mentioned, if you're just getting started with computer science, or maybe you know a friend who's trying to get into programming, I think Brilliant.org is one of the best.
Like, I have a little bit of an opinion on computer science. I think if you really want to get into programming and learn programming, you should do your own research, and you should try to teach yourself, because most often it depends on the university. Of course, we've had that discussion before, but if you have the wrong university, and oftentimes many of them are, you will not learn enough programming to be of value to anyone in the company, to anyone in the industry. So you will still have to learn programming after your degree. And so I would encourage anyone to actually go and learn programming as you're doing your degree. Doing the degree is still fine, I think. It depends on if you want to do it or not.
Best places to get your start, because they have these really high quality, engaging, interactive courses that start off extremely gently and actually teach you how to think like a programmer. You won't just be sitting back and watching videos that you can zone out of. Instead, you'll actually be interacting with the teaching material, dragging all of these things around, for example, to set the flow of this program, and being constantly quizzed to make sure that you're actually retaining this information and learning properly. But it doesn't just stop at computer science. Brilliant's math courses are amazing. The thing about teaching math that I think is so important.
Who needs math courses, huh? We don't.
Is that you teach it visually, which is why I think Brilliant is just such a great fit for this, all the way down to their everyday math course and through to more advanced topics like linear algebra and calculus. They have this beautiful visual interactive teaching style the whole way through, which in my experience not only makes the learning fun, but also drastically helps with you actually retaining.
You should react to math course.
And as I mentioned, you can get started for free. Just go to brilliant.org/the channel. Link will be in the description below, where you can get a 30-day free trial to check out all of the courses that Brilliant have to offer on their platform.
If you want to support him, go there, guys.
This video. So going back to the
channel, I think the channel's making good videos. You know, I know that some people really don't like them, but I think he's making good videos. You know, and so far what he's been saying, I think it's has Hand und Fuß in English. Okay.
I was just talking about. As we talk about ways that we could improve this system, I think it's important to realize that there's a certain trade-off of the complexity of the system really that is to be desired, because this at the end of the day is a very simple project, it's a very simple game. There's no real engine to this either. If you have a look at this over here.
If this is a simple game and look at all of these header files, holy shit, and all of these CPP files, shouldn't there be just one game CPP file? And then look at this flying entity, flights table. Ooh, menu CPP. Ooh, okay.
The game and the engine, like the game and the core systems are kind of linked together. I mean, you can really see that they're linked together because, again, the resource manager literally explicitly lists everything it loads. We've got like random facts over here. Okay, we've got regions and coordinates and airports, and everything is included within this resource manager, which, again, I would definitely change that design to instance. We want to be able to say is a very simple project. Here we've got regions and coordinates and airports, and everything is included within this resource manager, which again, I would definitely change that design, but that's just the nature of this. This is not supposed to necessarily be some kind of reusable framework. And I think that one mistake that can happen a lot with software development is that people don't understand sometimes that things are meant to be.
So how I see this, like we saw that he was loading a file here, right? So the airports txt file, you can see that he is creating a string out of the region, and then he's indexing into a txt file when he loads airports. I think this is just simple file loading, and the resource manager should, in my opinion, revolve around giving you files, and you build that path in your game, and then you have a load airports in your game, and then the resource manager is just loading the file essentially for you. And then it tells you, oh, I could load the file or I could not. This is how you could decouple those two very easily. So this code, just copy paste this into the game, create a load airports function in the game, and boom. It's foreshadowing. This is his conclusion. Oh, I see.
Cool. This resource manager, which again, I would definitely change that design, but that's just the nature of this. This is not supposed to necessarily be some kind of reusable framework. And I think that one mistake that can happen a lot with software development is that people don't understand sometimes that things are meant to be simple. There's no need to overcomplicate certain things if you're never going to reach that scale where it matters. Instead, all you're doing is wasting your time potentially, unless you enjoy it. If you're doing it for fun, obviously knock yourselves out, but you're going to be potentially wasting your time as well as overcomplicating.
I think this is just something that happens to everyone that starts to program systems. I think this is just normal lifetime of a programmer. So I made these mistakes in the past too. And then I learned that, wait, I shouldn't do it like this. I should do it differently, because I started using my system and it wasn't scalable. So I'm a huge proponent of just writing what you think is the right thing, then start using it, and then you will see the flaws in what you wrote, and you will ultimately improve. I think that's the best way to do it.
In the code, which is going to make it harder to deal with for both you and other developers. So because of that, we're not going to approach this the same way that I would for Hazel, for example. Instead, I'm going to try and find that balance. And so the first thing that I think we can hopefully all agree on is
we get rid of
shouldn't
this.
be here.
This
and
should
so
be
as
in
I'm
the
doing
game
this,
renderer,
in the back of my
stuff.
mind, probably the front of my mind, the thing that I'm keeping track of here is simplicity. I'm trying to make sure that this ends up being possibly even more simple than it is right now. So let's take a look at the structure of this, because one of the first things that stood out to me is the fact that this is a singleton, right? We have a deleted copy constructor, an assignment operator, we have a private constructor, and we have this static instance that we can...
I think I would just create, instead of like, obviously this is preference and how you want to program, right? I don't really do classes with constructors. What I would do is I would just create this resource manager on the stack, or maybe even as a static global variable, and then pass that around. That's how I would do this. Because you're asking the resource manager a lot of questions, right?
C, first of all, gets
Stack,
initialized basically.
Or the heap, but mostly it depends on how big this is, right? Because this is not going to hold data for you. Unless it is supposed to be like a collection of data, then it can't be on the stack, of course. Then you have to allocate it on the heap.
We call it, and then it just persists forever. So I don't really
I would
like
just give it as a static in one translation unit. Yeah, that's what I would do too.
In this way in C++, and the reason why is C++ simply does not need singletons. In languages like Java and C#, you have no way really around writing this kind of singleton setup, because everything is a class. Everything has to be a class. In C++, you can just do that, for example. And this obviously is out.
Oh yeah, so wow, like pre-watched. Holy shit, this guy's pre-watching.
Side of any kind of class, it's just sitting here in global space. We're limiting the scope to just this file, this translation unit, by using the static keyword. But other than that, like...
Mr. Cakez, do you think a sentence that includes please is a bannable offense because it dictates what to do? Just asking said. This is absolute brain rot, and the journo is sick in his head. Happens a lot with C++ devs down the line, get stuck in his weird mindset and do things for no reason. Okay, Mr. Collector of Stuff has earned himself another ban. We have about 15 minutes left. Let's give him a 20-minute break so he can cool his head. Truth equals ban. True. See you later, bruv. And let's enjoy the video. I'm sorry, this guy is just... He has some some, you know, he's a little bit too mean to other people, okay? We don't do that. We don't talk bad about other people here, okay? Let's move on.
Like, it's just suddenly global now. That obviously achieves the exact same thing as this. However, it gives us some additional flexibility with lifetime. Not this specific way that I've written this, but I think that the lifetime of a resource manager might be important. The reason why is because these resources need to get unloaded somehow. And I think that that's something that people don't really think about. And to be fair, I'm a little bit like on the line here. I'm a little bit on the fence as to how important that actually is. The reason why is because this, again, is a small game. There is not going to be any kind of resource unloading during gameplay, as far as I'm aware of.
Probably not.
I don't think that's necessary. So then the only reason we'd be unloading them, releasing these,
when
is
you close
at the very
the game.
End of the application, when we close the application. But that brings in the...
So making it static will automatically just unload the resources when you close the game?
Argument of, well, do we need to unload them if we're just terminating the application? The answer technically is, well, no, because the operating system will automatically clean up all the memory, obviously, when we terminate this application. It just gets reclaimed like that. It's much, much, much faster than us going through and actually...
I like that he points this out, because oftentimes I see people saying that, oh, everything you open, you also always need to close before you close your program. And then you hit X on a program and it takes 10 days to close. Well, it's essentially repeating the same process that the operating system would repeat for you in reverse order. So you allocate a bunch of stuff and then you deallocate this before you close the game. Why not just let the operating system do that? I know that in the past this kind of had to be done as far as I know, but I could be wrong here. Please correct me if I'm wrong. But for the most part, you just don't free shit. You just close the game, unless there's a real life cycle in the game that needs to be freed while the game is running. I'm talking about resources that get allocated once and never get freed during the life cycle of your game. Those resources can just be that the operating system can do that.
Freeing each
and
resource
it's so
and visiting all of these, clearing the memory, doing everything. We're like tidying up after ourselves, and then the operating system's like, yeah, you didn't really have to do that. I'm just gonna clean everything up. It's kind of like if we were, I don't know, demolishing a house and we went in and we just cleaned all the floors and we just made sure that everything was sparkly clean, and then we're like, all right, now you can wreck it. Now you can take the house down. That's just like, why? Why would you clean the floors if you're about to demolish the entire house? Yes, it might be better and it might be all clean and nice and like, yay, but functionally there's no difference. And in fact, what you've done is you've just wasted time. However, shutting down like an instance of a graphics API.
That's correct for stuff that needs to do a shutdown pass, like saving to a disk, and obviously RAI, you can't avoid once it's there. Yeah, but we're assuming that we have one big allocation. So I'm not really talking about RAI. Well, yes, that will happen. And yeah, the shutdown pass, like for example, saving a log file. This is something that you would need to wait for, essentially, unless you just stop right there. But this would be the, like for me, the only thing that really needs to hold up a program is log file writing, and that's it.
Yeah, like Vulkan, for example, it really shouldn't be done until you actually free all of the resources that you've allocated through that API on the GPU. And if you don't do that, it'll yell at you. So that could be potentially reasons for freeing resources. I think
some things need to be deallocated, like in Vulkan. I have done Vulkan deallocation and I have done Vulkan non-deallocation when closing. And I never had issues. Vulkan seems to free itself on my system. I could be wrong here, but I have used Vulkan in both ways. It probably threw warnings at you. It could be, but it's been a while. We would have to write another Vulkan renderer for this, to test this.
The biggest reason to do it is probably not for this use case, but almost just...
No. You guys have the wrong idea. You probably use the Vulkan allocator, the VMA allocator. It doesn't free properly with AMD drivers on Linux. Okay, so Travis Roman has been writing Vulkan too, more so than I have. And he's been working with Linux more so than I have. No, even with no allocator, no. The Vulkan doesn't even know that you're closing the program. It's just gone. I might be wrong here. Again, It's been a while since I wrote Vulkan.
Because it's a bit of a habit. So to give you a real world example, when I was making Hazel, the first time I set everything up and I had like a project being loaded in the editor, I could like go around, load all the assets, I could build my game, build my world, whatever. I had that up and running, everything was fine. And I didn't really need to rely on any kind of system to unload these assets because that was it. It was just that one kind of project, that one scene. We could build it up, you could hit play or whatever. And at the end of the day, it just ends with you hitting the close button and closing the application. But then we added more scenes. We added more projects. You had like a project, a game that you were working on, and then you could be like file open and open a different project entirely. So then what happens?
You need to unload the project
and all the assets and the resources that were associated with it.
That.
Well, because we had no mechanism to unload assets at all, they kind of just live on. They kind of just...
I think I would program this today. If I were to make something like this, I would create a ginormous arena and then just set the counter of the arena to 0 whenever I unload the project and load a new one. That would be instant. All of the resources gone in an instant. Boom. And then I load a new project. And I start allocating from the arena again. Now, obviously, I waste a bunch of memory space then. But as far as I know, even memory allocations will not use the RAM unless it's actually in physical use. So for example, let's say you allocate 20 gigabytes from your system and you can do that of RAM, but you're only using 1 gigabyte in your program. It will show like this one right here. It will show you memory usage of 1 gigabyte instead of 20 gigabytes because the 19 other gigabytes that you allocated are not in use. And so you could potentially do that. That's the first thing that I would do until I hit issues. And then we would do something more complicated.
Stay there because we didn't really have that facility to clean up after ourselves. And I think at the end of the day, that's what it comes down to. If that was quote unquote properly designed from the very beginning, then we would just have that just naturally. It would naturally be able to be like, okay, you switch projects, these assets, they're tied to the lifetime of this project instance. So therefore, when the project instance dies, all of the assets get taken with it because I'm doing stuff correctly.
I would write the program in a way where I don't need destructors. So for example, let's say we have a scene in a level and we want to load a different scene and then unload the previous scene. So let's say we have a game where we have enemies, the player, and some obstacles and maybe pickups. Now that's for me, this is just 4 arrays. And what do? Well, when I set the arrays to 0, they're empty. So I just set a counter to 0. I would program it in a way where the data that I need is just resettable by setting a counter to 0, and then it's like an instant reloading. What about a scene graph? Though, like in an engine, like he's talking about, is scene graph where you have what you're talking about is a bunch of nodes that are child objects of other nodes. I would keep that flat and keep it an array too. And so then I just set the counter to 0 and load the scene graph of the next one. I would have to test that, of course. I've never programmed this, but this would be the first idea. Array with relative pointers or array with IDs. Yeah. Array-oriented programming. So we'll see, right? Anyways, it's a bit too much because we don't know.
Tied to actually like parents, I guess, that encompass their lifetime, such as, for example, a project with a bunch of assets. The assets shouldn't just be global, shouldn't just be in a singleton. They should be relative to that project so that when the project dies, all of the assets die. If I had
so like a scene would be a ginormous struct with a bunch of arrays needed for that scene. And then that's it. That's how I see it.
Designed it from that way in the beginning, then when I expanded and when I scaled and I had suddenly more than one project, everything would just work just like that with zero effort from my part, with zero thinking about like, I should redesign this. I don't have to do any of that because it's kind of properly designed from the beginning. And I think that that's, again, at the end of the day, that's what this comes down to. It's the fact that like, it's not really much effort for us to make sure that we are thinking about these things, and it's a really good habit to get into, and it means that future development is likely going to be just a bit more flexible and a bit easier. And again, the biggest argument to this is, yeah, but I'm not going to do any more future development. This is all the game needs to do. And to be fair, that is potentially hard to argue with, but I think what it might come down to, it's kind of like an
if you finish your game and it works, who cares, right? So ultimately, think about Undertale and how successful that game is, and the programming is all over the place. The guy was probably new to programming and he enjoyed making a good game, and then he never really tried to improve his code like crazy, like we do, for example, those nerds, those programming nerds, and it still works.
Just making sure that their work is up to a particular standard. As a programmer, you are somewhat of an artist. You're an artist engineering this masterpiece.
I think we have to be careful not to go too much into this direction. It will take too long, like we do. Okay, you're banned.
As a C++ artist,
I can't ban you, your moderator.
Things that you always think about is memory and thus so lifetime of resources. Okay, so with that being said, let's move on because I feel like I'm maybe getting a little bit too deep. I don't know. This is, as I mentioned, a new format. Let me know what you guys think in the comments section below. Am I going into a bit too much detail? I don't know. Okay, so first and foremost, let's talk about how we're going to be handling the lifetime of this particular object. So as we know, the object has all of this data associated with it. When should that data be initialized and when should it be deinitialized or freed or killed or whatever? The simplest way I think to handle this in this specific project is going to be probably just going to be to stick it into the main function, to be completely honest. The reason why is because that's where it initially lived and there is no application class. I might initialize this in the application class if there was one. In larger systems, you might actually have a specific project, as I mentioned, that the resources belong to. So then when you load that project, when you initialize the systems related to that project, that's probably where you would initialize that resource manager. And then when the project gets killed, when
I would put the resource manager in the main function.
Initialize like all of the systems associated with it, like
try catch the whole program,
resource manager. So I'm trying to kind of keep this the same. This, by the way, was from the code review. This wasn't originally here, but it's a bit of a similar idea to what I would have. So what I'm going to do is I'm going to have a resource manager. It's going to be a pointer, and I'm going to call it G resource manager. Now you don't have to use this G underscore prefix.
It's global,
I like using this for global things. You also don't necessarily have to store this within this file, but you will need access to it in some way. So what I could do...
Guys, how did he make this green circle? I like that. That was cool. How did he do that?
This might be a little bit better actually.
G-string.
I'm going to cut this, or actually copy this, and put it into the resource manager implementation file. So that way, this resource manager is going to basically have a pointer to the only living instance of itself. So what I've done over here is very similar to the Singleton way, and we're going to use it in a very similar way. It's just subtly different, but this subtle difference is going to come with all of the benefits.
So like he's doing the same thing that I do actually. For example, I have sound state here that encapsulates all of the data for sounds, and I have a global sound state that I allocate when I start the program. He's doing the same shit as I do, man. Interesting. That's the global sound state that I talk to. Interesting.
So the first thing I'm going to do is I'm just going to make this null pointer. But there's a few things that are important about this. First of all, you can see it's not tied to any particular scope, right? This is just a global variable at the moment. It's present in this one single place. It's a pointer and it's set to null pointer. That's all it is at this point in time. We obviously want to be able to use this though outside of this class. So what I'm going to do is I'm going to go to this resource manager, and somewhere here, doesn't really matter where, I'm just going to add in, let's maybe come down after we declare the class, and we'll say extern resource manager G resource manager. The reason why I'm adding this into this header file is because I want this to be present basically everywhere where it's included. And because this is...
What is this? Like, did I just miss like a key feature of C++? If I include the resource manager header file, I have this available. Why would I turn this to extern? One translation unit. He's designing it so that you can add a header to many files.
Marked as extern.
Instead of just one file.
When this gets included into a...
I have a Unity build system, and so for me it works because I include this only once. But I guess what you're meaning is I define the same instance twice if I include it twice, and then I get issues. So that's why we do extern. And then it's just one pointer. I see.
Files such as main.
Okay.
So by including that header file, we're
that's the reason
including
for
this code. It means that it's not going to create a new variable called GResourceManager, because that would be obviously weird. We have a different pointer in each file. That
I get it now. Thank you guys.
Set to anything. It's just going to reference that existing one. If this was a function, we would simply have like the function prototype with no body, and that would be fine in the header file. But because this is a variable, we have to use this keyword here. Another way you can technically do this is you can actually go into this header file and just have inline resources manager, G resource manager, and then you can set it to something like null pointer. I think possibly these days I might prefer that. The reason why is because it means that if you go over here, you don't need to have this. It's effectively a global variable, but it's just in a header file, which means that you don't need to have it actually defined in the CPP file. You can just have this single mention of it in the header file, and that's it. And then when it gets...
Extern creates an unresolved link symbol in the current source directory when you're going from C to 0. C++ to 0.
Included, it won't be
hello, low-level learning. Good morning.
A new variable, right? So if I make this global like that, that's not going to work because everywhere where I include resource manager, it's going to be its own version of
2.0, not 0. What does that mean? 2.0. I'm a big fan. Good morning. I don't understand it in object file. So when you're going from C++ to object file, it creates an unresolved link. Okay, but if I do extern, I still have to define it somewhere, like he did, right? But if I do inline, then it's essentially here. I get it now. Okay.
That G-resource manager variable, which isn't going to work because they're global variables.
This works for like projects where you have multiple translation units. Yeah, I have one and therefore it works for me. But for other projects where you have multiple and you include the header multiple times, then you need that. Well, thank you very much for following low-level learning.
You already have this variable defined. You can't define another variable with the same name. That's not going to work.
For the
Static,
info.
same situation. It's going to mean that each translation unit has a unique copy of G-resource manager.
Yeah, so that's what I had to deal with too. So once I made it static and I had more than one translation unit, I had this multiple times over, and that sucked, which is why I created
inline comes in to save the day because it means that there's only going to be
single
one
translation
copy of this throughout the whole application. So actually, I think I would rather solve it this way. Now, if we go down over here into instance, we want to be able to potentially use this through this instance API. Why? Well, potentially two benefits. It might look a little bit nicer than referencing G-resource manager directly, even though we can. But also note that this is a pointer because I want to specifically create an instance of it at a particular point in time, but this is a reference. So if we just return G-resource manager and then dereference it, it means that we don't then have to later dereference that pointer or use the arrow operator to access its members. We can just call dot. And also...
Yeah, I mean, I'm starting to use references too because it's starting to get annoying, the arrow operator sometimes.
By keeping this
but I still think pointers have their place because you can check for null pointer. Especially when you're trying to get an entity, by ID or something, and then you return. You could have like a 0 entity, but you're still returning a lot of data. A null pointer is more or less easier to return because it's just essentially an int, a very large int, compared to a big object. But I guess a reference is also just in int. STD optional? Yeah, okay, let's not talk about that, okay?
Of the usage of this class throughout this code base. So from the point of view of this API, nothing's changed because that instance function is still there. I've just kind of changed the underlying implementation of how that singleton is created and just made it like a global, really, more than a singleton. So then over here in main, that is where I want to initialize this. I'm going to call G-resource manager equals new resource manager, like that. This at the moment is private, so we have quite a lot of options, really. We could make this public. We could probably make the main function a friend function if we wanted to. I don't think I've ever done that before.
Friend functions, yeah, I used those in the past too.
So if we did friend int main. Oh, that feels weird, doesn't it? I've never done that in my life.
Okay.
Let's go back and see if this even works.
This is why I write C-like code, okay? The friend stuff, public, private constructors, functions and structs.
Control 7 to compile that, and yep, okay, I am a mad scientist. I don't know if I would do that. What this would do is just limit it to the main function, right? So if I had another function here, anywhere else, this is not going to work. It's going to tell us that it's private. However, because this is the main function, we're allowed to access it there. It's probably not the worst thing in the world. Again, I wouldn't have this in the main function to begin with.
Friend is not your friend, lol,
to the rest of the current code. I'd probably have this in some kind of application or project initialization function to begin with. That's where I would initialize the resource manager. The other thing you could do, because I don't think I'm going to do that at the end of the day, to kind of stop this or at least make it a little bit better, is you could make a static function here called create.
No, you could just use structs.
Which assigns to that, or call it init. That's just going to make it, I think, a little bit cleaner, and it's going to handle that implementation. The reason why is because you might not know that to initialize the resource manager, you have to just create a new heap allocated instance like this. And then what if that allocation coming from the heap with the new keyword, what if that strategy changes? So what you could do instead is have like a static void init, and then if we just create a definition for this, what this could do is just do G resource manager equals new resource manager, or obviously within the resource manager class. So this can remain as private like that. And then from main, this looks a little bit neater as well because we go from this code to just that, which I think is cleaner, right? So what that does is it creates the instance.
No, I don't like this. So here's what I do, and I think that's better. Objectively, subjective, of course. We learned that the other day. This is subjective, of course, but I think this is better. So essentially, if I needed to have initialization code for this sound state, I would just call init sound state or something, and then supply the sound state like that. I think this is better. So I allocate the sound state and then I initialize it. That's how I would do it. Just having the init function here, I don't know, because it does two things. I don't like that too much.
Now, we obviously want to shut it down. That was part of the whole reason we even had this. So let's go over here and I'm going to call resource manager shutdown, which doesn't exist yet. We're going to go back to resource manager to init. I'm going to duplicate this, make a function called shutdown. And then if we create this, that's just going to call delete resource manager. And then I'm going to set resource manager to null pointer. Why? Because just on the off chance that we try and use it later, it's going to be nice if we run into a null pointer rather than a random memory address. Because what happens is if we delete this, sure, it's deleted the resource manager. It's freed that memory. But what is resource manager?
It's like the
array
variable
index, guys. That's a pointer. And what is a pointer? An integer. I have a whole video where I say that like 50 times. I'll have it linked up there. Pointers in C++. I think that's over 1 million views now, which is crazy. Classic Cherno back in the day. But anyway, the point is, it's just a number. So obviously, if resource manager is set to, this, for example, just because you've deleted what's at that address, you haven't actually changed this number to 0, right? And that's what this code does over here. And again, the only reason to do this, if you're shutting down, usually you don't care. Like if this was a member variable, I wouldn't set it to null pointer because the whole class is dying. But because this is a global variable that we can theoretically access anywhere else.
So like, I don't even know why we would need to do this at all because we are closing the program. I would only do this if we need to clear this and load a new resource manager and continue the program. But I think the resource manager is tied to the application. So this doesn't do anything because we are not accessing the resource manager after we have shut it down. Unless we want to assert that clearing the resource manager worked. It goes against what he said earlier where he said that we should just let the operating system free the resources.
It just means that we won't accidentally access it potentially. And if we do, we'll easily see that, oh, it's null. It doesn't exist. It either hasn't been initialized or it has already been shut down. And you could even, into instance where we retrieve it, because obviously this will crash, you're dereferencing a null pointer. You could even have some kind of assert where you just make sure that, this is not null, basically. Kind of like that. Okay, wonderful. So we have an if.
I think crashing is better, but assertions are good too. Yeah, they help a lot.
We have shut down, and if we go back to main, we can see that we have very clearly defined this lifetime. Now, I've written this in a bit of like a heap memory version where we have init be an actual pointer that we allocate on the heap here. There's quite a lot of stuff going on here, and because this is like a core system, I probably would have it be a heap allocated system, but you don't technically have to. We could have also used RAII with just resource manager to actually allocate it here. So we could have had our resource manager instance here, had some facility to retrieve it. It becomes a little bit murky in my opinion, even though technically possible. So what you could do, and this is going to be a little bit wild, but if you did want to perhaps automate this init and shutdown so that you don't forget to shut it down, you could almost treat this kind of like a scoped pointer or a unique pointer. This is why this series, I think this new format is fun because I can just go into random thoughts like this. So hopefully you guys are enjoying it. So if we just had like a struct here called system, what I'm going to do is inside the constructor, I'm just going to call t-init.
Now we are initializing it and then we're cleaning it up.
Okay,
what the fuck's it talking about?
Here, I'm just going to call shutdown.
Don't be negative,
so
Mr. Collector
of
stuff.
This very simple kind of class, I was going to call it class.
That's too confusing. So this is where I stopped doing C++, by the way. Not to shit on him, like everyone that likes doing this, that's totally fine. But for me, this is too complicated. It's just too complicated. I like having essentially a nice little letter or book to read. So at the very top, I say, I allocate this. Maybe I do a defer deallocation right then and there. And then I just move on. Like all of this stuff is hidden because now I create a system. I need to look into system. What is system initializing actually? Aha, this is all it allocates. And then I need to take a look at the deallocation stuff of system and take a look at that. And then in my main loop, I just have some random system where I don't know what system is. And then I see system init or system, allocation. So basically, just system. Cakez shouldn't strawman, bro. That's not a strawman. You're wrong.
The class though, right?
He's creating a simple helper, yes, I know. It can be done in many different ways. And I said, like, if that works for you, that works for you. I'm talking about myself. Templates can be very powerful when used in the right places, especially with concepts. However, this is weird. I think this is a bit weird. Yeah.
Doing init and shutdown, all we can do is just do system resource manager, and then, I don't know, RM if we wanted to. And then we don't need shutdown. But since we have this nice scope here,
I think this is hidden
again,
now.
use RAII if we wanted to make sure that we didn't forget to shut it down. Would I do this? Probably not. I just think it's like a lot clearer if you just have resource manager in it and shut down. There's also no ambiguity as to when it gets destroyed, like in what order. If you had a few different systems and they had to be shut down in a particular order, then I would prefer this. It's much more clear. All right, so I suppose we should test this code base. I don't know if it will compile if I've left stuff in it, but let's just test this to make sure that it basically still works.
I wonder what type of game he's made.
So
you know, airport, flight info.
Variable.
Sounds interesting.
Yeah, this I just forgot to delete. So let's try and run this again. All right, there's our game. Let's do Iceland. And there we go.
Loading.
I mean, I guess that works. Seems like it works. Okay. So this video just ended up being about the specific lifetime and the Singleton and how to kind of rewrite it into something
Minecraft
a little bit
music,
better.
cool.
Do you agree with the changes I've made? Does it make sense why this is
mostly agree.
better?
I think those are good changes. Yeah.
Yes. That's okay. Let me know in the comment section below. Now that
I think the game should load specific resources for the game, and then the renderer should load specific resources for the renderer, or even the game passes the renderer data to be loaded, like font files and stuff. The game says, oh, I want these types of fonts in the game, and then it supplies them to the renderer, which then loads the font, or then asks the resource manager for font. So like you would disconnect this, and then you have a generic kind of resource manager.
Handled the lifetime, which again, I think is the most important, one of the most important things just in programming in C++ in general, but specifically for something like a resource manager, very, very vital. Now that we've handled this, next time we're going to move on to actually, hopefully, like rewriting the rest of this resource manager. Hope you guys enjoyed this video. Let me know what you thought of the new format. Don't forget to hit the like button if you did enjoy it.
Of course.
And I will see you next time. Goodbye.
Goodbye. Thank you very much. I think this was nice. And let's see here. If you guys want to support the channel, this is the original code if you're interested in this. It's public on GitHub. And so if you want to take a look at this, here it is. This is the code from the video. I think that's really interesting. And then if you want to support the channel, I guess I'll link the video because there's most of the information. Shit React, you're banned. 5 minutes.